Okay, section 4.5, direct variation. So tonight we're going to take a look at equations that fit a certain format, and we call that general form direct variation. This is a pretty easy lesson, so just make sure you pay attention. I want you to understand the deeper meaning behind everything. Okay, it says two variables vary directly if there is a non-zero number k such that the following is true. And then you see it says y equals kx. Okay, this y equals kx is the general form for a direct variation equation. And this should kind of make some sense to you. So, we're always going to have x and y in an equation. Here, x is kind of like the input, and then here y is the output. So x and y, input, output, they're what form your ordered pairs. But then we also have this k guy lurking right here. So my first question to you would be, what exactly is the k doing to the x? And when you look at that relationship, hopefully you see that it's multiplying the x. So I want you to think of the k as like a multiplier of the x. So if we had an equation y equals 2x, okay, that k value is 2. Or y equals 3x, that k value is 3. Y equals negative 10x, okay, that k value is negative 10. It's just letting you know what the multiplier is. And we have a name for this. We call it the constant of variation. Okay, so k is what we call the constant of variation. Constant because it's never going to change. In the equation y equals 2x, that 2 will always stay a 2, even though we might plug in different values of x to get out different values of y. Okay? Two quantities that vary directly are said to have direct variation. So I want you to understand what direct variation means. And in simplest terms, this is how I think of it. When one quantity goes up, the other quantity goes up. Okay, so one thing goes up, it causes something else to go up. Specifically, as x increases, y will also increase. When we look at this on a graph, we see an increase in the x value, and as the x value increases, the y value, where it ends up, will get higher and higher. And a couple things fit this relationship. We're talking about a linear relationship here because we're talking about a line. But for example, as time goes on, as the years pass, okay, our ages get higher and higher. And the more years that pass, okay, the higher our age becomes. It's a very predictable relationship. So as time goes up, age of something goes up. This isn't a perfect example, but let's look at years once again. So as time increases, here maybe as we're thinking about decades are increasing, the price of gas goes up. Okay, and that price fluctuates. It probably looks something a little bit more like this when you think about it. But if you were to average out all of the price fluctuations and maybe put a best fit line to it, we know that over time, because of inflation, that type of stuff, gas prices are going up. Or maybe an even better example, let's think about Bruce Lee, okay? The faster Bruce Lee's arm goes, the harder his punch will be. And if he can throw his arm even faster, then the punch will just become harder and harder. And this comes from, I think it's Newton's second law, an equation, force equals mass times acceleration. If you look at that really closely, it's very similar in format to the direct variation equation. Okay? The k, the constant of variation here, is Bruce Lee's fist. Okay? Bruce Lee's fist is a certain mass. It's not going to grow or shrink. It's going to be constant. Okay? The only thing that we can really change is the acceleration of it, how fast he's going to throw that punch. And it makes sense that as that acceleration goes up, the force of his punch will also go up. So direct variation, one thing goes up, it causes something else to go up. And I want you to kind of keep that in the back of your minds, because we are going to come across this again in the second semester, and you're going to need to remember it because we're going to talk about some other types of relationships that aren't direct. Okay, the graphs of direct variation models are going to do two things that I want you to remember. One, they will always go through the origin. So that's the point 0, 0. So expect your linear graph to go through the origin. And the other thing is the slope of the graph is going to be given to you in the equation. Okay, so the equation is going to fit the format y equals kx, and that slope will be the exact same as whatever this number is. So that k value will tell you the slope. If you go back to the examples I gave you earlier, y equals 2x, it has a slope of 2. Y equals 3x, it has a slope of 3. Y equals negative 10x, it has a slope of negative 10. So they're going to be giving this information away to you. You're going to automatically know the slope as long as it's direct variation here. Okay, go ahead and take a look at these two graphs, and then I want you to just kind of mentally come up with an answer to this question. Why is the second one not an example of direct variation? Well, the first one is direct variation because one, it's linear, and two, it goes through the origin right here. Okay, so as long as it's linear and it crosses through the origin, it's going to be an equation that looks like y equals something times x. Over here in the second one, it does not go through the origin. Right now I'm circling the origin, and there is no line going through that point. Okay, it actually crosses the y-axis up here, 5 away from the origin. And so in the equation, this is going to look like y equals something times x plus 5. Okay, with direct variation, we're not going to have a plus or minus at the end. It's just going to be y equals some number k times x. So if that graph does not cross the origin, it is not direct variation. Okay, so one of the things you're going to be doing in the assignment is you're going to need to generate some equations that are direct variation equations. And this is pretty simple, but I want you to not try to just do it in your head, but to actually perform the algebraic steps. It's going to help you once things get harder. So it says the variables x and y vary directly. When x equals negative 3, y equals negative 30. And I want you to do two things here. Okay, the first thing you're going to do is write an equation that relates x and y. And the second thing you're going to do is find the value of y when x equals 8. And this is a blue example, so you do need to have out your paper at this point. I'm going to walk you through the first one and then let you do some of the other ones on your own. So on your paper right now, go ahead and just write number 1. This will be the work that I expect to see from you. Okay? The first thing you're going to do, since you know you're dealing with direct variation, it says that they vary directly. So I want you to write down the general form for direct variation. It's y equals kx. Always start here. Okay, you have 3 variables. You don't know all 3, but you do know 2 of them. Which ones do you know? Well, it tells you up here that when x is negative 3, y is negative 30. So something that we perform a lot in algebra is we plug in what we know to figure out what we do not know. So in your second step, you're going to take that negative 3 for x and that negative 30 for y, and you're going to plug them into their spots. So the y becomes a negative 30. We still don't know the k, but we do know that x is negative 3. So when I plug in a negative 3, it spits out a negative 30. What is that number k that's causing this to happen? Well, we can work backwards to figure that out. Notice I use parentheses there because the k is multiplying the negative 3. All right, to get k by itself, to solve for k, what would we do? Well, we divide both sides by negative 3. So you'd want to show that on your paper. Divide by negative 3, divide by negative 3, and you're going to end up with k equaling 10. Okay, you're not done. You've just figured out what your constant of variation is. So your constant of variation is 10. It's the multiplier of the x. Okay, if you go back up to the question, it wants you to write an equation that relates x and y. That means you have to have an x and a y in your equation. If you just stop right here at 10 equals k, that's not good enough. There's no x and y in there. Remember that because you're going to forget it. Okay, so let's take that 10 and plug it in for k, and our general equation is going to be y equals 10x. So that is the equation we're looking for. Now, on that graph, on that linear graph of that equation, -3 comma -30 is going to be 1 point. But you know there are going to be many, many, many other points. So one of the reasons we try to find out this equation is so that we can learn what other xy coordinate pairs also exist on that same line. And that's kind of what number 2 is asking you for. If you go back and reread number 2, it says find the value of y when x equals 8. Well, that's good because now that we know our equation, y equals 10x, and you can just do this along with me, I'm going to plug in the 8 for x and see what it spits out. Okay, much like a function, right? Plugging in the 8 for the input, and then I'm going to crunch the numbers to see what it spits out. So what does y equal here? It equals 80. If I were to plug in a 5, then y would equal 50. If I were to plug in a 10, y would equal 100. If I plug in a -2, y equals -20. And I could go on and on and on, figuring out more and more points of information. So that's the basic process here. Okay, so just reviewing one more time, because this is the way I want you to do all of them. To find that direct variation equation, always begin with y equals kx. Plug in your values for x and y, plugging in -3 for x here, -30 for y. Divide both sides by -3 to isolate the k, and you figure out that k equals 10. Now you know your k value, so your equation, therefore, is y equals 10x. And then to find any point, plug in whatever input they're asking you to do. So we know that y equals 10x. We plug in an 8 for the x, and it spits out an 80, just like that. Okay, so you should have the work that we did together on your paper. Now I'm going to ask you to start doing some of these on your own. So look at this next one, example 2. It says the variables x and y vary directly. When x equals 4, y equals 20. And here I just want you to write the equation. So they always have to tell you that something is going to vary directly or has direct variation. That way you know that it's going to fit the form y equals kx. Okay? So go ahead and go through the same steps here, come up with the equation that relates x and y when x equals 4, y equals 20. All right, good luck. Go ahead and hit pause now, and then when you're ready, unpause. We can reconvene to go over answers. Okay, let's go ahead and take a look at how you did. Now, you should have an equation, and it needs to have an x and a y in it, because I'm asking you to write an equation that relates x and y. Okay, always begin with the general form here, y equals kx. So if you know its direct variation, it should fit this form. Plug in what you know to figure out what you don't know. So I know that my y value in this one specific instance is 20, and in the same instance, the x is a 4. Okay, from here, it's a basic one-step equation. You're going to divide both sides by 4. And that's going to give you your k value. So your k equals 5. Okay, don't circle that, you're not done. Okay, what are you going to do with that 5? Well, you're going to come back up here and plug it in 4k in the original equation. So instead of saying y equals kx, for this problem, we're talking about the equation y equals 5x. And that's your equation. If I were to ask you, hey, what's the slope of this line? Okay, remember, the k value gives that away. This has a slope of 5. That means it's going up the roller coaster, and it's very steep. Right? You should be able to visualize that. If I were to ask you what's the constant of variation, same thing. Okay, that's just another way of saying the k value. So the slope and the constant of variation are going to be the same number. So I hope you got that right. Y equals 5x. Okay, let's go ahead and try another one. Here I'm asking you to do two different things. So get the equation first and then find the specific y value on number 2. It says the variables x and y vary directly. When x equals -4, y equals 28. Okay, so first thing, write a direct variation equation relating x and y. And then after you've done that, tell me the value of y when x equals 5. Okay, go ahead and hit pause now, and then unpause when you're ready to go over answers. Okay, let's see how we did. Number one, all this work's going to look very similar. I begin with y equals kx. I plug in what I know to figure out what I do not know. So it says that the y value is 28. Still don't know the k, but I know that k is multiplying the x, and the x was -4. Make sure you write that down as a -4 and not a +4. So to figure out what the k is, I'm going to have to divide both sides by -4. And when I do that, I figure out that the k equals -7. Don't stop there. They're asking for an equation. That -7 is just your k value. So your equation should be y equals -7x. Okay. If you were to graph this thing, would it be going up the roller coaster or down the roller coaster? Hopefully you said down. It's a negative number. Is it going to be steep or gradual? It's going to be very steep. Okay, so you should be able to visualize it. All right, secondly, it says find the value of y when x equals 5. So we're just plugging in a 5 for x here. So I'll go ahead and skip the first step and just plug the 5 right in for x. And -7 times 5 is -35. And if you can't really visualize what's going on here, basically we're asking for points on the t-chart, right? The first point they gave us was -4, 28. And kind of what we're getting at here is like, okay, what's the equation that connects these two so that if I want to know other points, I can figure out other points. And knowing that it's direct variation, it's going to fit the form y equals kx. So we know that the equation is y equals -7x. That way, if I want to know, hey, what's the output if I plug in a 5? Well, that output is going to be -35. Okay? And you can go on with as many other points as you'd like to discover. Okay, last one. Very similar here. Be careful on this one. Don't just rush through and do this in your head. You need to do out all the steps. I'll expect to see it on your papers when you turn this in. It says the variables x and y vary directly when x equals 72, y equals 6. So same deal, write the direct variation equation in number 1, and then find the value of y when x equals -24 for number 2. All right, go ahead and do this on your own. Make sure you double check it, make sure it's right, and then unpause when you're ready to go over answers. Go ahead and pause now. Okay, let's see how we do here. If you're one of these type people that likes to do mental math a lot, and I was one of these guys growing up, I totally get it. But if you like to take shortcuts and you're looking at numbers like 72 and 6, and you're like, oh, I see the pattern now, it must be 12, so the answer is y equals 12x. Well, you get caught here. That's wrong, right? So if you came up with y equals 12x, you probably were trying to take some shortcuts. There's always sort of two ways you can go at this, so you want to make sure you always begin with y equals kx. This is going to keep you organized and make sure that you have the right relationship. And here what's different is the y value is actually smaller this time. So it's a 6 for the y and a 72 for the x. And that might seem kind of freaky in your brain, right? So I plug in a 72 and it spits out a 6. In all the other examples, I plugged in a number and somehow it got bigger. Well, this one's getting smaller. Well, how does that happen? Well, multiplication can still be at play here. You're just going to be multiplying by a fraction. You don't have to think about it right here. Just perform the algebraic steps. Okay, you want to unglue the k in the 72, right? So go ahead and divide both sides by 72. Kind of like an algebra robot. And you get 6 over 72 equals k. And that can be reduced to 1 over 12. So your k value here is not 12, it's actually 1/12. And if you need a crash course on reducing, which hopefully you don't, but if you do, you got something like 6 over 72. Remember, you can divide the top by 6 and the bottom by 6. And that gives you a 1 and a 12. So that's where we're coming up with that 1/12 number. Okay, you're not done. That's just your k value. I never said that the k value had to be a whole number. It can be a fraction, right? You can have a fractional coefficient there. So your equation is y equals 1/12 x. And hopefully you came up with that. Okay, now we're going to use this to figure out what the value of y is when x equals -24 in number 2. So let's go ahead and see. Y equals 1/12 x. Well, I'm going to be plugging in a -24 for the x value. And don't freak out with fractions, right? If you need to do a little side work for this, which what I do sometimes, there's no shame in this game. You can multiply them by writing them both in fraction form. That means that negative 24 gets written as negative 24 over 1. I usually feel a little bit more comfortable when I have a top and a bottom times a top and a bottom. And so top times top, I get negative 24. Bottom times bottom, I get 12. And negative 24 divided by 12. That's a negative divided by a positive. I get a negative. It's going to be negative 2. Okay? So the value of y when x is negative 24 is just going to be negative 2. So you can write y equals negative 2 as your answer statement. Okay? Pretty easy stuff, but this is going to lay the groundwork for getting into slope-intercept form in the next lesson, which some of you guys may have experienced in middle school. Okay, good job and good luck on the assignment.